All right. Oh my, Yerpy. What do you think? Is that Yerpy? Can you see this? Oh, sorry. Let me get this on here. You're like, what are you saying? All right, sorry. Hang on. Is it Yerpy? Erpy. I'm gonna say Erpy. Erpy wants to buy towels online. There are two stores with the kind of towels she wants. The first store and the second store. Okay. The first store charges $20 per towel. Timeout. And the delivery charge is $25. Let's write a formula, an equation, in slope intercept form. Okay, where n is the number of towels, just like this one. Can we do that with these two numbers? What would that look like? Tell me. 25 plus 20, and then let's call it n just like they do. Okay, no big deal. Question is down below. Which store charges more per towel? The first one does, right? Easy enough. You can look right here at the slope. Right? That's your slope. That's your rate of change, right, Dean? There you go. So the first store charges more. Now, it could be that since, there's a difference here, right? There's a difference between the delivery charges. So it could be that one is still cheaper than the other, even though it charges more per towel, right? How could we check on the effect of this 15 towels? Plug it in. Let's go. Who's got it plugged in? Somebody does already. What do we got up here if we plug 15 in? Is it 325? Okay. Okay, and how about this one? Plug 15 in there. 305. So even though the per towel cost is higher up here, if you only need 50, or now that you need 15, right, this one is still cheaper, even though the delivery is lower, right? You get what I'm saying? Okay. So the first store is cheaper. Wait, I said that wrong. Second store is cheaper. Okay, that's how one of these problems will look. Another one looks like this. The only difference is we've got to kind of figure out the slope. They give us a table to do so. All right, so let's do this. Two young sumo wrestlers decided to go on a special diet to gain weight rapidly. They each gained weight at a constant rate. The weight of the first wrestler as a function of time is given by the following table of values. Oh, wait, I don't have that problem here. Shoot. Give me a sec. Let me find it. Pause. Unpause. All right. So we've got one table for this sumo wrestler, and we've got a graph for this one, right? The question is, which wrestler gained more at the beginning of the diet? All right, let's do this. What's happening? How much weight was gained over how much time? Well, it went up 1.5 months here, right? In between there and there. How much weight was gained in kilograms? 6.75. Somebody divide that for me right now. What do we get? Was it 4 point what? 4.5? Okay. That's 4.5 kilograms per month. How about down here? All right, let me zoom in on this a little bit. We've got a graph. Well, we haven't looked at graphs yet, but we can here. Let's pick a couple spots on the line. Just pick those two. We went from 75 up to 90, right? So that's up 15 kilograms over the course of 3 months. We can do that in our heads, right? That's 5 kilograms per month. So question is, again, which wrestler weighed more at the beginning of the diet? We haven't figured that out yet, have we? All we found is the slope. So what do we need to do? Well, we need to go back in time a little bit here on this table. We know that they gained 4.5 kilograms and they did it 3 times, right? 4.5 kilograms per month. So let's do 4.5 times 3. Somebody tell me that. 15.5? 13.5, yeah. So let's go back 13.5 kilograms. If we go back 13.5 kilograms, then this would be 81.5. That's where they were at month 0, right? The question said, which wrestler weighed more at the beginning of the diet? Where did this one begin? 75. So we have 75 versus 81.5. So this is wrestler 1. Yeah, that's what they're calling wrestler 1. Which wrestler gained weight faster? We just answered this one, right? We had 4.5 kilograms a month versus 5 kilograms a month. Oops. So in that case, the second wrestler gained weight faster. So the only difference between this question and the first one was we had to kind of extrapolate from the table, right? We had to figure it out from the table, what our slope was, where they started off, and so on. I'm going to assign that to you. We'll work on that tomorrow at the start of class.